Hello, so we need to be able to solve quadratic equations and disguise quadratic equations by factorising or the quadratic formula as shown now. So for example, here we need to first solve 3x cubed minus 17x squared minus 6x equal to 0. I can factor an x out to get x of 3x squared minus 17x plus minus 6 equals 0. So that means x equals 0 or 3x squared minus 17x minus 6 is equal to 0. And then to solve it, to show my working, I can quickly jot down the quadratic formula. 17 plus or minus the square root of minus 17 all squared. Take away 4 lots of 3 of minus 6 all over 2 lots of 3. So if I do that in a calculator, I get x is 6 or x is minus a third. So overall, x is 0, overall x is 0, x is 6, or x is minus a third. Okay, part B, now we have a disguised quadratic, we need to find the real solutions to this equation here. And hopefully you notice it's very symmetrical to the top one. But, so then we could say, hopefully we can use the substitution, x going to be y minus 2 squared. So that means the solution to the top equation via the substitution means it will also be a solution to the bottom equation. So then if I have these three roots for x, and if x is equal to y minus 2 squared, therefore y minus 2 squared is either going to be 0, and so therefore y minus 2 is going to be 0, so then y is 2, or y minus 2 squared is going to be 6. So y minus 2 is plus or minus root 6. So y is 2 plus or minus root 6. Or y minus 2 squared is equal to minus 3. But that has no solutions as we can't square root. So that means in general, overall, we have y to be 2. Or 2 plus root 6 or 2 minus root 6, and there we are. We can also square both sides of an equation if necessary to solve it that way. So 5x add 3 is root 3x add 7, so we can square to get rid of the root. So then 5x add 3 squared is 3x add 7. If I expand the bracket, I get 25x squared, 5 times 3 is 15, another 15 get 30x, and then 9, and then I take away the 3x and the 7 to get it to equal to 0, so then 25x squared, add 27x, add 2 equals 0, then I can solve that. Let's just note down the formula to show my working to get minus 27 plus or minus the root of 27 squared, take away 4 lots of 25 of 2, all divided by 2 times 25. So then I get the solutions x minus 2 over 25 or minus 1. Okay. So then as I squared both sides of the equation, I need to check all my solutions by substituting it back into the original equation. So firstly check x is minus 2 over 25. So then 5x add 3 be 5 lots of minus 2 over 25 add 3. That would be 13 over 5. Then if we also check in and put it in the other side of the equation, so root 3 lots of minus 2 over 25, add 7, we indeed get 13 over 5. Great, so they're both the same, so it is a solution. Then we need to check x is equal to minus 1. So 5 lots of minus 1 add 3, that's going to be minus 2. But then if we put that into root of 3 lots of minus 1, add 7, that will get me root 4, which is 2. Well, so minus 2 is not equal to 2, so that means they not satisfied the equation, so x cannot be minus 1, so only x is equal to minus 2 over 25 there. So we can square both sides of an equation, but you need to check for incorrect solutions by verifying your answer at the end. So with that in mind, we first need to find here the solution to 16a squared is 2 root a. Well, again, we can square both sides if we want to. So squaring 16a squared is 256a to the 4. Then if we square 2 root a, that'd be 4a. Then we can move the 4a to the other side to equal 0. So then we can factor a 4a out to get 64a cubed minus 1 equals 0. So that means either a is 0 or a or a cubed is 1 over 64. So a, if we cube root, we get a quarter. Okay, but as we square rooted, we need to squared both sides. We need to check both solutions. So if a is 0, well, obviously that will work, because then 16 lots of 0 squared is 0, and 2 root 0 is 0. Great. Then if a is a quarter, then 16 of a quarter squared, that would be 1, and also 2 root a quarter would also get me 1. So both are solutions. So a is 0 and a is a quarter. Okay, part B, we have b to the 4 plus 7b squared minus 18 equals 0. So this is a disguised quadratic. If I said u is b squared, then we get u squared at 7u minus 18 equals 0 as an equivalent quadratic. Okay, now we can solve this. So let's set the formula. So minus 7 plus or minus the root of 7 squared, take away 4 lots of 1 lots of minus 18 over 2 lots of 1, which has a solution 2 or minus 9. Okay, but then that's u, so then b squared to get to b. So b squared is 2, or b squared is minus 9. Well, b squared is 2, so b is plus or minus root 2. And b squared is 9, we can't root a negative, so it has no solutions. So overall, b is root 2, or b is minus root 2.